Hello, Honors Algebra. Mr. Lawrence here with your flipped lesson for Tuesday, March 27th. You see it says March 28th because that is the answer key for the 28th. Let you know we're going to be having a test on Friday of this week, okay, right before break. Actually, yeah, I think Friday would be a good day. All right, so if you're going to be out Friday, you're going to need to make arrangements with me ahead of time because I'll tell you, you don't want this test to go over spring break. You will do very poorly on it. Okay, so talk to me ahead of time and we'll make some kind of arrangements and have it take it early. All right, let me see here. Here is the answer key for you for the story problems that you started in class. Okay, hopefully you're starting to lose your fear over story problems. Now, some of you just see more than 3 words in a math problem and you freak out. There's nothing to freak out over. They're really simple. You just have to plug in the values and then solve. Okay, so there they are, the problems, and if you need to see them longer, certainly you can pause the video. Okay, we've been working off of this equation now. H equals negative 16 t squared plus or minus v sub o t plus s, okay? And remember that this is your starting height, right? Oh, excuse me, that's your ending height. Excuse me, silly me. This is your ending height, and that's why we so often want it to be 0. S is your starting height, okay? T is time, and we're actually in seconds. Now, if we were given like a velocity that wasn't in feet per second, maybe it was in miles per hour, we would have to convert it, okay? And then this is my initial, meaning beginning velocity. Okay, I don't know if you realize this, but when an object is thrown, it's going at its fastest the instant it leaves your hand. Okay, because after that, things start to affect it. Gravity starts to pull it downward. It's traveling through air, etc. Okay, so it's the initial velocity that matters. And we're not really talking so much about throwing this way, which we could, but we're talking more about throwing up. And so instantly, this ball, or whatever is being thrown up, maybe it's a baseball, or getting close to baseball season, this ball is going fastest right here. It goes up and 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 up. And if you kept a radar gun on it at its peak, it actually would register 0 at its peak. It would have to, because it slows down and then it speeds back up again. Okay, so in effect, it almost stops. It certainly doesn't stop and hang there, but it goes, the velocity goes to 0. Okay, now, one thing that I might need to clarify is the speeds, neglecting air resistance, the speeds on both sides will match. So if I have a ball here, okay, on the descent, its speed matches right there. Okay, yeah, they'll match. Okay, and then it'll be going fast again here and then eventually hit 0. Okay, so I initially said that it'd be going its fastest when it leaves your hand, but that's not 100% true because it can accelerate. Now, in this class, we don't get into all the air resistance, the drag, and that kind of stuff. We kind of neglect it, pretend like it's not there. Later on in physics classes or in higher math classes, you'll start to account for that kind of stuff. Okay, but we're pretty much considering that we're in a vacuum here and that things aren't being slowed down, so to speak. We know they are, but anyway. Okay, so if we have a problem where, say, I don't know, you got a kid's on top of a roof, right, and throws a ball, and maybe that distance is, I don't know, 40 feet, okay, and he throws a ball. Where's my, I don't have it on this one. All right, no problem. Throws a ball with an initial velocity, say, of 35 feet per second. Okay, that's the initial velocity. We can figure out how high the ball's going to go. We can figure out how long it'll take before it hits the ground. All different kinds of things. So let's go ahead and use our equation and figure out two things. We're going to figure out how high, which you should be thinking of a V word right now. What's that, Zach? Yeah, vertex. That's the V word I was thinking of. Finding the vertex will tell me how high. And we're also going to figure out how long it's going to take before it hits the ground. How long before it hits the ground. Okay. All right, so I know my equation is h equals negative 16 t squared plus v sub o t plus s. Are you wondering why there's a plus or minus? Minus would be if I was like throwing it downward, right? If I was throwing it down with initial velocity. Certainly, if I drop a ball off of a roof, it'll fall slower than if I throw it downward. And if you'd like me to demonstrate that in class, just ask. I'll be happy to throw one of my little splash balls, you know, the real soft ones that don't hurt, and throw it, slam it down into the ground. And you'll see the dropped one will fall much slower. Okay, so the ending height is going to be 0, right? Negative 16 t squared. I'm solving for t. The initial velocity was 35 feet per second. And then my starting height was, what did I say, 40 feet. There we go. Okay, now I want to show you a real cool website I found. Hold on a second. Okay, hopefully you can see the little the address, but if not, it's www.math-is-fun.com/quadratic-equation-solver.html. All I did was go onto Google and type in quadratic solver, and quadratic equation solver came up. All right, now you do need to be able to do a quadratic equation on your own and on the test. I'm going to need to see your work. But while you're doing homework, you know, if you just want to check an answer after you've done the work, well, you just plug in your values. So, for example, here, I'm going to plug in negative 16 for A, right? I think B was 35. Okay. And then C, what was my starting height? 40 feet, I think. Okay. And there you see part of the parabola, but notice it changed them. I didn't even have to enter or anything. And it shows me the roots right here. Here are my two roots. Okay, here are my roots right there. And the negative root is the part like if it were being launched from the ground. But it's not being launched from the ground. It's being launched at a higher altitude. And so, therefore, I'm going to discard this negative one. And I know that's going to hit in about 3.02 seconds. So about 3 2/2 of a second. Okay, so just a hair over 3. Now, by the way, look at all this information it gives me. It gives me my discriminant. Okay, it gives me the actual vertex. So I'm going to do the math for you in a minute, but I know it's going to hit its peak in about 1 1/10 seconds, roughly 1 900 seconds, and its peak height will be 59 1400 feet. Okay, so this is a really cool site. Check it out. It can help make your homework a little less frustrating. Now, of course, if you just go and plug everything in here and write your answers down, when it comes time for the test, you're going to fail miserably, right? This is supposed to be a tool to help your learning. All right, so let me get back to the problem here. And you can go back and check those answers and see if I got them right when I'm done with my math, but I would like to work through it in case you're having difficulty. So, let's see here. I know that A is negative 16, B is 35, and C is 40. All right, so I'm going to do T equals negative B plus or minus square root. I know 35 times 35 is 1,225. That little trick I do about things ending in 5. Okay, minus 4 times 40 times 16. And let me see here. I'm going to put that all over negative 32. I'm going to simplify that as much as I can. Negative 35 plus or minus. I have 12, 25. And I know I'm going to get a positive because I think I missed a sign right there. Yeah, my A is negative. So I'm going to get a positive here. Now, I'm thinking that if I double 40 and double it again, that's going to be the same as multiplying by 4. So I'm going to hold on to that. 16 would be to double, 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 and then double one more time. So it looks like I'm going to have to double 40 a total of 6 times, because this is 2 times 2 times 2 times 2. That's where I'm getting those 4 doubles. And this is 2 times 2. I'm just going to double 40 6 times. So I'm going to get 40. So there's 1. So it starts right here. So there's 1. 160, there's 2. 320, 3. 640 is 4. 1280 is 5. 0, 6. 2560, it'd be 6. So I should get, you can verify that, but 4 times 40 times 16 should be 2,560. That's all over negative 32. And I'll simplify one more step, and t is going to equal negative 35 plus or minus. Okay, let me see here. I'm a vertical kind of adder. Okay. 3785. Let me just see. Do I have that up there still? 3,785. Yep, there's my discriminant right there. That's what I was supposed to get. So you see, I can use this tool to help me reassure myself and feel like, oh, I'm doing an okay job. All right, I got to put this over negative 32. And now I'm ready to go ahead and solve. So at this point, I'll go to a calculator. I think I've got my calculator here. All right, it's taking a little bit. Quit. Oh, I'm still running a program. Quit. All right, so I'm going to go negative 35 plus the square root of 3785. And then I'm going to divide that by negative 32. And there is that negative answer, the one I'm going to discard. And so then I'm going to go second enter to get back there. Change that sign in front of the square root to a minus. And then divide by negative 32. And I'm going to get that number that's just a little bit more than 3 seconds. So, you know, rounding to the nearest hundredth, I would say that t is approximately 3.02 seconds. So in other words, it'll take just over 3 seconds for that ball to hit the ground. Okay, to whomever I'm throwing it to. Now to get the vertex, remember I'm going to use this part of the quadratic formula. My x coordinate is going to be negative 35 divided by negative 32. Okay, and negative 35 divided by negative 32 is the same as 35 divided by 32. And I get that about 1 in 900ths. So I'm going to be 1.09. All right, and then I go back to the quadratic formula. Actually, not the formula, but the original equation right here. And for t, I'm going to plug in 1.09. Now, I know my answer is going to be off a little bit because I'm rounding. So negative 16, 1.09. And if I want, I can go 375, and then my answer will be much more accurate. The calculator is going to do the math for me, so I'm not so worried about it. I think it was plus 35, 1.09375, and then plus 40. And it should shoot out the y-coordinate of my vertex, which is 59 1400ths of a foot. So let me see here. So the vertex occurs at 1.09 and 59 1400ths feet. So that means the max height, this part right here, is 59 1/4 feet. And it takes, what is it, 3.02 seconds for the ball to travel this hyperbolic path. All right, one last question for you. I want to know, and you may not be able to answer this, so we're going to discuss this in class. If you had a gun, okay, and inside the gun was a bullet, and this bullet was identical in every way to the bullet you were holding in your hand. Okay, so you have a gun in one hand with a loaded bullet and a bullet in the other hand, an identical bullet. Now you fire the gun, and this bullet, the instant it leaves the chamber, you drop this bullet. So this bullet begins to fall like this. At the same time, this bullet is going down like that, right? It'll travel. Now we're assuming my gun doesn't look very horizontal. Let me see if I can fix that. We are assuming that you are holding the gun horizontally, and the bullet will travel in a path something like this, right? We know it'll be part of a hyperbola because the instant that that bullet leaves the chamber of the gun, gravity begins to work on it. Now this bullet just simply falls straight down. Okay, I want to know mathematically. I don't want you to look it up and say, well, my dad told me the answer, or I found this. I want you to use your mathematics, particularly this equation. H equals negative 16 t squared plus v sub o t plus s. Okay, use this equation and see if you can tell me which bullet will hit the ground first. And again, we're going to neglect air resistance. All right, Mr. Lawrence signing off. Have a good night, everybody.